Hi, everyone. Welcome to this episode of Tech Talks. My name is Simran, and I'm joined here today by Ray. We're going to be talking about DevOps, ROI, and vanity metrics, and what really matters when we're trying to push to deployment. Well, hello, everyone. Welcome to this episode of Tech Talks with the DevOps series. My name is Simran. I am a software engineer here at InTime Tech, focusing on DevOps and data engineering. And with me today, I have Ray.
Hi, I'm Ray. I'm a senior engineer at InTime Tech. I've been here with InTime Tech just about exactly 4 years. I've been doing DevOps probably about I don't know, half of that time at least. Um, yeah, it's like I originally got into DevOps on an Edison project about I guess about 3 years ago, when that was my first real DevOps project, although I've done DevOps related things, I think, throughout my career. So,
Awesome.
what about yourself?
So I've been at InTime Tech for about a year and a half now. Um, I've been doing, DevOps related activities for quite a bit of that, and even before that in college, just a tad. Um, my first big DevOps project is Atlas, which is one of our internal tools that we've been working on, and I was brought on to help kind of deploy that up and make sure that's all running good. Um, Still kind of, newer to the space, but have a profound interest in a lot of those things. Yeah.
Cool.
So today we're looking to talk about DevOps ROI and vanity metrics and what real DevOps ROI looks like versus these other KPIs that a lot of people talk about in business conversations that often don't have to do with the final, value of DevOps.
Right. Yeah. I mean, when we talk about vanity metrics, we're talking about measuring things or gauging performance on metrics that don't really give you insight into how your DevOps, software pipelines are functioning or how much value they're delivering.
Right, right.
Um, I don't know if some of the examples of those might be just the number of commits or merge requests
Right, right.
or, just lines of code,
Mm-hmm.
which is not really relevant, and hasn't been relevant probably for some time, regardless of what practices or methodologies you're using.
100%. I know on Atlas sometimes when we're trying to do our deployments, there's multiple commits that happen. Like we'll do like 20 or 30 of tweak this little thing, remove a couple lines of code here, add a couple, and none of that really has to do with the value provided when we're doing some of this work.
Right, and there are different philosophies when it comes to what should be included in a commit or what you know DevOps might practices might say encompass organizational best practices regarding how often people should commit, but that in itself is not necessarily a valuable metric, because you, of course, with the goal of DevOps is to improve the flow. Well, I mean, if you think about, you want faster delivery of higher quality software.
Right.
So, of course, you want metrics that are going to give you insight into where your bottlenecks are or where you might be experiencing issues with code quality.
Right. DevOps ROI really is delivering customer value faster. Has nothing to do with lines of code, has nothing to do with commits, and there's a couple metrics that do actually matter. One example is lead time for changes. How long does it take for an idea to go from code to production?
Right. You get a feature request through whether it be a project manager, say, or a product owner, and that's going to be vetted through your project management.
Mhm.
And ideally, you're if you're using the agile methodology and you're using stories and features and and tasks, you should be able to track the development and integration and deployment of that feature, um, from the time it's requested through the time it's deployed.
Right.
And you should have metrics that allow you to do that. Um, so you want you want to focus on observability. What is going on in the whole process.
Right. And that's where something like mean time to recovery might come in as well. The observability of how long is it taking when something fails to recover back. Right. That's another metric
Right.
that's
Yeah.
pretty valuable.
Yeah. You want repeatable processes, and one of those is being able to recover um, when, for whatever reason, and it could be a problem with the code that you deployed, or it might be um, an operational problem.
Hmm.
You have this tight coupling between development and operations, or tighter coupling, and where you have through DevOps control over uh, the environment that the code is going to be deployed to.
Right.
And sometimes it's a matter of inadequate resources, and sometimes it's bugs with the code. And mean time to recovery can expose um, issues, like if you have a website go down, you know exactly what caused it to go down, number one, and then how long does it take to fix the issue that caused it.
Right. Right. And one really interesting thing with that as well, um, a lot of DevOps and deployment and even development in general is kind of just waiting time. Um,
Right.
and so one of the big things about DevOps ROI is how do you decrease that waiting time to make it so we're not waiting between different steps to get something deployed, fix failure, and how do you streamline that process?
Well, you want to have real time KPIs, key performance indicators. Say, if you're waiting, if you have a policy in place in your pipelines where you want to have say 2 approvals before a merge request can be completed, and you wait, those KPIs will tell you, it's like, well, okay, we were waiting on a merge request before we can do this build and deployment.
Right.
That would, your KPIs should give you an idea where those blockages are. I think an analogy I like to think of, because before, I mean, this is going years back. I mean, but when I was in school, I worked for wood grain millwork in Nampa, and we was manufacturing, solid core pine doors. Um, and of course, occasionally, in the process of building panels for these doors, I ran a machine called the panel raiser, and there was we were the end step of a whole process of uh, ingesting, raw material wood, and um, creating the panels, and then sawing them and sanding them, and then I would run them through the machine that shaped them into their final shape. Um, uh, Manufacturing at the time was implementing practices involved with just-in-time manufacturing and continuous process improvement.
Hmm.
Um, occasionally we would have issues with, like, say, this big belt sander might have small fires, which would bring everything to a halt. Um, so tracking issues like that, they were able to improve, or identify the problem and make improvements in. And I forget how exactly they fixed it, whether it was just improving the finer grit, the sandpaper, or changing it more often, or whatever. But analogous to that would be, yeah, okay, well, we have uh, builds failing because we have, not enough, or we're waiting to do builds because we don't have enough build agents available. So it's a bit like applying manufacturing processes to software,
Right.
if that makes sense.
That's a good analogy.
Yeah, I mean,
No.
I've been um, back in the day. I don't like anyway. My experience in the software industry has been over the years, and DevOps really wasn't possible. I don't think until um, you get to. I mean, certain things had to happen in the industry before DevOps was possible. Things like server virtualization and um, high speed bandwidth, um, as far as networking and um, massive amounts of storage
Right.
and memory and things like that, as well as changing the way software is deployed. Especially um, where most apps are deployed as web apps these
Hmm.
days versus when I started my career, it was all client server, and you would have to deploy an application, say, on hundreds of machines or
Yeah.
possibly thousands, where you didn't really have control over the environment, and you would send people a little executable package. So nowadays, it's like as long as somebody has a web browser,
They can access
they
your
can
app.
access the app.
Right. Right. Speaking back to, way back when, like you were
Yeah,
saying, I feel like it's the combination of those new, emerging technologies, the
yeah,
increase in bandwidth, as well as some of the failures of the existing ways that things were kind of being done.
right,
Having siloed development and operations really, really slowed things down. Like I said earlier, DevOps ROI, it's all at the end of the day, it's kind of how do you lessen the waiting? How do you make it less of a waiting game?
right.
Previously, development would write some code and then, they'd do all their PRs and whatnot. They'd have their final app ready to go.
Yeah,
And then they'd have to pass it basically over a brick wall or
right.
through a brick wall to operations who would then get this code. They have no idea what's going on. They just have to take the code and then figure out how do we,
Yeah, it's
put it
like
up there.
you give 'em some specifications, like it needs these resources, say pre-installed on a server or whatever, um, and you would turn it over to them and you would hope for the best.
Yep.
And if something went wrong, I mean, you would have people whose job it was to support the application, and hopefully, they would be able to quickly identify the problem. If not, they would have to go back to the people who developed it and get information from them. So having that um, tighter integration between development and operations, that philosophy of eliminating those barriers, um, for increased trust and transparency.
Yeah. And that's what really increases, DevOps, the return on investment, the ROI of having DevOps
Yeah,
resources, paying for certain tools and deployment. It's that you can lessen that waiting game. You can save your
yeah,
developers time and you can get your product out to your customers faster.
yeah. I mean, it's that pull model. It's like rather than deciding on a feature, behind the scenes, you get, you have feedback from the users of your application, and from that directly you produces the backlog of features that you want to implement. You'll be able to do that faster if it's you'll get there quicker, faster, and that will increase revenue and make you more competitive and save money in terms of downtime or underutilized resources. If you're not waiting, if you have developers or, waiting to have a merge request approved, because developers are lazy and they won't say anything. Um, Drinking coffee or whatever. Um, if you can identify places where it's like, well, we need to make sure people know it's their job to, approve merge requests, and, say it's like, well, let's set some standards for the time it takes to either approve or deny,
Right.
a pull request or a merge request.
Right. Another DevOps metric, an ROI metric that I think's kind of important is deployment frequency. And so that one's kind of interesting because just pure deployment frequency as is isn't necessarily the most important thing, but it's the ability to deploy in a frequent manner once new code
Right.
has come out that can be really valuable.
Right. You have that option. I mean, it's if you don't have a reason to deploy something, if you're, and that's why I might question whether deployment frequency is really a valuable metric. I think you might look at it more in terms of, again, how long did it take you? More
It's
importantly, how long did it take you from the request for that feature or to fix that particular bug or
very
whatever?
speed to deployment,
Right. Yeah.
right?
The total velocity.
In your experience in the DevOps field, where have you really seen some of these vanity metrics kind of, confuse confuse, I guess, leadership? Not leadership. Where have you
Yeah.
seen these vanity metrics kind of confuse the business side, where they're kind of looking at the wrong things as opposed to, some of these proper ROI metrics we've discussed?
Well, I think, in the early days, I could think back to my first exposure to DevOps was probably about 2013,
Hmm.
2014. I was doing some work for bodybuilding.com, and they were just looking at, like, well, say server uptime or
Hmm.
number of commits. And it's like, um, just looking at those vanity metrics didn't, because there were features that needed to be implemented that weren't being worked on or tested adequately.
Right.
Um, so they were just looking at, like, okay, is the website up? Are these apps up? Not just the website, but their mobile apps versus what are we delivering code to where the applications are responsive and their users aren't experiencing interruptions or errors,
Right.
um, and that there are we're covering security vulnerabilities.
Right. Like you said, server uptime really isn't really important either.
Well, I mean, and especially when a lot of times, and one of the things that enabled the advent or the of DevOps was, of course, cloud
Hmm.
services, cloud computing.
Yes.
Not that you have to deploy software to a cloud, but um, the cloud environment gives you a lot more. Uh, not, I mean, there's control, but also flexibility with regards to the deployment environment.
Right.
And so there's that using infrastructure as code, which some people include as a part of DevOps and some people don't. But um, yeah, sometimes you want to be able to say it's like, well, we've got this feature and we're experiencing a blockage. It's like maybe at least geographically in some areas, it's like, well, what can you do? Well, it turns out, with cloud services, you can ensure that you deploy your app or, you know, um, be able to cache, across multiple geographic regions
Right.
rather than, just
De- de-
one big
so deploying to one,
data center.
your
Yeah.
users are going to have latency issues depending on where
Yeah.
in the world they are, and so you can deploy in different, edge
Right.
regions and
That gives you not, it gives you better performance in those regions because when it comes to websites, there's oftentimes a lot of images or video or things that could take up a lot of bandwidth that you can cache geographically and make it a lot more responsive. So that's a consideration that you aren't necessarily going to take. I mean, it's an architectural decision, um, taking it, when the app is built. That's kind of, I mean, and the developers have to be aware, to have to build in certain functionality to be able to take advantage of things like like caching across multiple regions and things like that. And then, so again, there's the value of that tighter integration of that, breaking down those barriers between development and operations.
Right. So
Also, it sounds really cool.
does sound cool. One thing about these DevOps metrics in general, vanity or otherwise, is that often when they become targets, it can just get dangerous. Like
Right.
even the solid ROI metrics that we discussed, if you focus too closely on trying to meet certain metrics, you're not going to get the success that you're looking for out of DevOps.
Right. I mean, and too tightly focusing on a particular metric you can lose sight of the bigger picture of like, okay, well, we're trying to deliver value to our customer, whoever that customer is, whether it's an internally used app for an enterprise or it's an externally facing app. So if you've just focused on speed versus say quality, and you want to make sure that, change failure rate is a good metric because it's like, well, for any given set of changes, it's like how many errors or issues or bugs is that producing?
Right.
And if you can track that, you'll produce better quality code because the emphasis is not just on getting it out there fast, but getting it out there good.
Right.
Yeah. So, I mean, and that's ultimately how you're going to be able to determine your ROI. And ROI can be difficult to determine for DevOps for a number of reasons, but basically you can point to it and say, it's like, here's how many features we are able to deploy. And, here's what we believe it's contributed to revenue or cost savings or whatever. And then you can point to, it's like, well, this is either it's increased the amount of revenue per, I don't know, person working or, unit of compute time or whatever.
Right.
Versus, or we've saved this much by fixing these bugs or providing these additional features.
Yeah, but even to that extent, it's hard to measure.
It is, but you can there's intangibles like people will trust the software more. It's like, how do you put a value on trust? I mean, that goes into things like, I mean, from an accounting perspective, I suppose it's like goodwill.
Right.
Yeah. Which I'm not sure what the rules on that are, but yeah, just trust and I don't know if people like using your software. It makes it makes it easier to go to work. If your tools work, or the software can make a difference in how you perceive your job.
Yeah, that's a really important thing on internal applications.
Yeah,
is that you want someone there to make sure that it works effectively.
you're right.
Because when you have developers that are more excited to use these tools, they're gonna.
Yeah, I mean, when I first started in the industry, my supervisor at the time asked me, it's like, what I thought the point of writing software was, and one answer I gave was just, it's cool, or we just, it makes people, allows people to do things, and he said the point of this, what we do is to manage complexity, because people's jobs, people are quite often you have to do complex things. So if you can create software to mask or manage that complexity to where, they have less of a cognitive load to do their job and they trust it to do it correctly, then yeah, you've done your job well. If you've made their job harder, then you've done it wrong.
Right.
And we could talk a little about implementing security.
Okay.
And one of the things that's probably not talked about enough when we're talking about DevOps, except now people are talking about DevSecOps,
Mm-hmm.
which is where, one of the things that can happen when you're delivering software in a hurry is you can overlook security vulnerabilities. Um, so you want to have built in to that pipeline, that process of, developing and deploying your software, um, you know, uh, security considerations. You want to check for uh, where you're exposing maybe personal information, identifying information. You want to be careful you don't do that. I know at Blue Cross of Idaho, one of the things that we've really uh, cracked down on is personal health information or person identifying information also. So there are built in policies in that pipeline that look for where that might be exposed.
Right.
And that should be a part of your tool set, is to look at, are we inadvertently exposing people's information, or are we leaving ourselves open to be hacked?
Right.
I don't know if you've, experienced anything
In the
similar.
in the security space, not so much. I've had a lot of experience with the financial side, the cost saving side
Right.
of DevOps, which is also another metric that's not, inherently DevOps specific, but cost is a general point that you want to look at in a lot of software projects. Um, and I think they call this FinOps sometimes.
Yeah, that might be I haven't heard that, but that's interesting.
Yeah, financial operations, I guess. It's
Yeah.
working in the DevOps space to figure out how to make your resources not as expensive, how to lessen your cost. Um, and so one of the partners that I've worked with in the past was having some cost troubles with some of their resources, and so one of the things we had to do was
Or like people resources, or are we talking like compute resources?
compute
Okay.
resources, not people resources.
Those can be a problem too.
But yeah, so they were having some problem with some of the costs of their compute resources.
Yeah.
They were reaching exorbitant rates on some of their tooling because initially they didn't really focus on DevOps. They were just like, developers are going to deploy the code and the developers will figure it out. And the problem with that is, most developers aren't looking at the bigger picture and they're not considering certain aspects of things because that's not what they've done before, right? And maybe they're new to
Yeah.
this, or that's not something that they have the time. There's multiple reasons that might happen, but at the end of the day, having a developer try to deploy, without the bigger picture can lead to a number of issues. And so we had to go in and look at some of these resources and be like, this isn't set up right. This one's the plan that they use. This is always running for some reason, even though it's only actually being called once a day. And
Okay. Yeah.
they're using the complete wrong resource for this one. Like we're using a data warehouse for real time like
Oh, okay.
reporting instead of
Yeah. For
like a
an operational relational database for
exactly.
yeah.
And so there was a bunch of those problems, and so I had an opportunity with the team to go in there and help clean some of that up. Replace some resources, scale certain things down, migrate over to new databases, and at the end of the day, that saved them a lot of time and a lot of money.
Yeah.
Now that their infrastructure is set up better, they're able to more quickly push new changes, move more data around. They get their reporting faster, and it just, it doesn't cost as much. And so that's one of the big things in DevOps. That's where you're really getting the return on investment.
So one of the things you brought up is people are going to have to do things differently. A developer might be used to like, well, I just approve my own pull request or merge request or whatever, and just push it out there. Well, it's going to take a different mindset. So it's like, how do you convince people of the benefits? How do you change people's mindsets? And that can be the most difficult because people get used to doing things a certain way,
100%.
and I've been the same way. sometimes it's like, well, I don't want to do anything different. And as I get older, um, I am less enthused about doing things a different way unless I can really see a benefit in doing so. And even then,
Right.
it's hard.
Right. I mean, that's part of the game of DevOps is the communication side. It's like
Yeah.
how do we get this point across that we're trying to move on to this new standard, or this is our new tooling, or now when we deploy or when we do a PR, you have to do it this such way. And so oftentimes that can be a big struggle as well. And that's where often a DevOps team or DevOps engineers can come in and set that standard and help people adapt,
Right.
because a developer on a team, when there's a bunch of other developers and other teams and they're all trying to deploy their stuff, it's going to be hard to set a standard when that's kind of the structure that's going on. And
Right.
so when you have a team that's a little more focused on the deployment side and the
Where
cloud
you have
resources
where you
side.
have to think about that, you don't. I mean, and having done development, and I'm sure you as well.
Yes.
Developers want to use cool stuff. You want to do really cool, and it may not be the eh, best option, or might not make sense in terms of deployment. Um, to use the latest, greatest technology, it's like, well, I want to use this package, but well, it turns out there's security vulnerabilities with whatever it is you're trying to implement or whatever.
Right.
So for developers, learning to think in terms of what resources are going to be needed to build and deploy this, you know, where everybody's now responsible
Right.
for the deployment and the operations of it. It's like you don't have that division of like, well, I did my part, I developed it.
Yeah. See, now you have full ownership instead
Right.
over the app as a whole, as
Correct.
opposed to this, kind of siloed ownership structure when we had, traditional development and
Right.
operations.
Yeah. And then, if something goes wrong, one of the things that there's a tendency to want to blame.
Yes.
And one of the principles that isn't necessarily universal in DevOps, but I think it's beneficial is to have zero blame. It's like, it doesn't matter, you know, who, and usually there's more than one person
Right.
who's responsible if something isn't working right.
Yeah. Usually it doesn't matter who's
And it doesn't
responsible.
matter. It's like, let's just fix it.
Yeah. Fix it and learn so that it doesn't happen again.
I mean,
Or hopefully it doesn't happen again.
right. I mean, and managers will know, the general skill level and who's being responsible.
Right.
But at some level, it's like, everybody's responsible for the success of that application or that enterprise. And so when people take ownership of that, from cradle to grave, and when I say grave, it's like at some point, software has an end of life. That needs to be taken into consideration too. If people,
Right.
you need to consider how replaceable is this going to be. When people take that cradle to grave responsibility, then overall you're going to produce a higher quality product, and it's going to take less resources to produce that.
Right. And one of the things you'd mentioned earlier was that often, developers are excited to use all these cool tools and they'll build their code and whatnot. And, one point that I wanted to touch on is often when code is being developed, deployment isn't really considered at all throughout the
Right.
process.
Yeah.
And so that can often lead to a bunch of problems. And that also ties into the end of life part is that, we're deploying code to build something cool quickly. That's, part of the agile life cycle is we just want to get this done fast. We just want to get this out there. And what ends up happening is now we have this code that no one's planned, I guess, the life cycle for. And that's kind of the
Right.
operations side. It's like, okay, cool. Developers, the development, they made this really cool application. Now, how do we get it to users? And what do we do in 10 years when we're not using it anymore?
Right.
And, that's a big part of the ROI on DevOps is that you're saving time in the future on all of these choices
Right.
by making them now during development.
You might spend a little more time at development to save time and resources in the long run.
Yes.
A good analogy is, the space shuttle when they developed in the 70s. It's like, well, the Nixon administration wanted to save money on development costs, so they got a space shuttle stack that was cheaper to design and develop, but was extremely complicated and expensive to operate long term.
Mm-hmm.
And had 2 fatal accidents in the long run. So the same kind of principles I think apply to any kind of engineering, whether it's just regular engineering or software engineering. It's like you spend a little more time up front, and then you'll save money in the long run. Or save headaches as well.
You think of the life cycle
operationally,
ahead of time, and then your failure rate or over time, that goes down as well. I mean, it's just really valuable to look at that early instead of just saving it for when it needs to happen.
Right.
You never want to get to something and be like, you never want it to be this needs to happen. I feel like that's never really great.
And you have to consider all the activities. I mean, because very few apps that you're going to work on exist in a vacuum. I mean, especially if you're developing, APIs.
Right. It's
or
interconnected.
Microservices and things like that. You have to consider how it's going to integrate with
the wider
enterprise
system.
architecture, wider system. And if you're siloed, if you don't have that good communication, you don't have that idea of the big picture, you're going to have problems.
Right.
So it's something you need, that the saying I think in the military is, amateur study strategy, but professional study logistics. Well, there's a whole supply chain that needs to happen around software deployment and operations. And you need to be aware of that. I think the whole software design, development, and deployment process, is going to evolve. DevOps or DevSecOps is going to continue to evolve.
Mm-hmm.
And one thing, one lesson I can take from my career is that you can expect, massive amounts of change. And I think, right now we're looking at AI is probably going to be the biggest driver of change in how we develop and deploy software. So
100%.
I would look very closely at that space.
Yeah, I know we're already implementing AI into CI/CD processes and a lot of different facets of DevOps. But I guess we'll see, into the future how things really change. All we can do is wait.
And it depends on, there may be some unforeseen disruptive technology. Maybe it's quantum computing or whatever.
Yeah.
But don't. I guess the lesson I've learned is don't be too attached to one particular methodology or set of practices. Be flexible, mentally flexible.
Things can always change.
Yes, and they will.
Things will always change
in ways that you do not expect.
All right. Well, thank you, Ray, for coming on and for this episode of Tech Talks.
Thanks for watching this In-Time Tech podcast. If you'd like to learn more about what we can offer you, please visit our website, intimetech.com, where you'll be able to see the different capabilities and technologies we could provide you in your business. Also, don't forget to subscribe and follow us to get more amazing content like this. Thanks again, and we'll see you next time.